So let's go ahead and consider another example of trying to verify an argument or a proof. So here I've already written the example out, and I want to figure out if this is a valid argument or a proof. If there is a bug in my code, then my program will crash. There are no bugs in my code. Therefore, my program will not crash. Is this a valid argument or not? Well, once again, the very first step that we're going to have to do is translate this using logical symbols. So our translation step is going to look as follows. So I'm going to let P be the proposition there is a bug in my code. There's a bug in my code because I see that right there. And then Q, I'm going to let that be, well, program crashing. And if I look through this paragraph right here, I see, well, those are the only two variables that I need, only a P and Q. So to translate this into a format like an inference rule, it would look like if there is a bug in my code, so if P, then my program will crash. So P implies Q. The next hypothesis is there are no bugs in my code. So that would be not P. And what's the conclusion in this case? Therefore, my program will not crash. Therefore, my program will not crash right here. And I want to figure out, is this a valid argument or not? Even if I have memorized that table 1 from Rosen 163, I'll notice that this thing doesn't appear on it. So I don't know whether or not this is a valid argument or not. I'm going to have to verify it myself. And we had 3 different ways to do this. We could reason it out by looking at setting this hypothesis true, that hypothesis true, figuring out what our values of P and Q are going to be, and figuring out if that conclusion is always going to be true. We could use a truth table, or we could use our logical operators and laws and rules and apply those. I'm going to take the last approach. So to see whether or not this thing is a valid argument, I'm going to consider my hypothesis and my other hypothesis. Does that always imply my conclusion right here? So is this thing right here a tautology? So the approach I'll take here, instead of a truth table, I'm going to use my laws of logical operators. So I know this definition right here of this implication means I need to negate my hypothesis. And I leave my conclusion as is. I see another implication in here, so I'm going to apply that same definition. And here I see a not outside of an and that makes me think immediately De Morgan's law. And I'm going to have to apply De Morgan's law twice, again, in this case. So I'm going to distribute this not into here, and then I'm going to have to distribute the not over this or, and then distribute the not over that and right there. So doing 2 steps of De Morgan's law in one go, I get the following. So first off, this expression right here, applying my De Morgan's law, I get not P, which is simply going to be a P. I flip my or to become an and I get a not Q right here. And then when I applied De Morgan's law out here, I flipped the and to an or, and then this became a not P, which is a P right here, or not Q. And I don't put any brackets around here because I know that since I have a couple of ors right here, it doesn't matter the order of the brackets. So I can still do a little bit of simplification right here, because if you notice right here, I could distribute this P, this OR right here, into this AND expression. So I'm going to go ahead and do that distribution, and I get P OR P and P OR not Q. Great. P OR P, I already know that's simply just P by itself, so I can simplify that. P OR not Q doesn't look like I can simplify that. But here I see an expression with an and I see an OR, so I know that I can distribute this on the inside. So I'm going to do the first little simplification step. I know that this thing is just a P, and this thing is P OR not Q. And I'm going to distribute this OR not Q across this AND right here. So doing that, I get not Q OR P and not Q OR, and then this expression. Well, good. Here again, I see a not Q or not Q right here, because remember that with all these ORs right here, it doesn't matter the order, so I could rearrange them however I wanted. So I have a not Q and a not Q, that's simply a not Q. So this thing is logically equivalent to not Q OR P and not Q OR P. Well, this little and right here, it's the same thing on both sides, right? Not Q OR P, not Q OR P. So I know that this thing is logically equivalent to not Q OR P. Uh-oh. I was trying to show that this thing is a tautology right here. And that doesn't look like a true statement to me, because indeed I can consider, well, how are we going to make this thing false right here? Well, I could consider Q being true, and then that thing right there will be a false statement. And then P being false. So if I consider that case right there, then what do I get? Well, this argument has then turned into the following. P implies Q, so this P implies Q, in this particular example right here, is going to be logically equivalent to false implies true. And I know false implies true is a true statement. And my second hypothesis, not P, well, in this particular example, that would be a true right there. So both of my hypotheses are true in this example. And I'm trying to claim not Q. Well, not Q in this case is false. So this is not a valid argument. Both of my hypotheses right here are true. This hypothesis is true, that hypothesis is true, and yet my conclusion is false. So I can say that this thing here, no, this is not a valid argument. And indeed, we have a special name for these sorts of arguments right here, ones that are not valid. This here is what's referred to as a fallacy. So a fallacy is an invalid argument. And if you look in Rosen, he gives a couple of other fallacies and some names for these different fallacies right here. But again, I've been able to, in translating this down into some sort of logical expression, use all those rules of logic to be able to verify if this thing is a tautology or not. It turned out in this case that it is not a tautology, and I gave an example of where it's not a tautology, and therefore this is a fallacious argument. It is not valid.